Good morning, chemistry students. Here are your Chapter 6, Day 5 notes. We're going to do pretty much all of the rest of Chapter 6. All that will be left for our final day of notes is making a flow chart. But today we're going to kind of finish up our notes from the textbook. Again, we're going to talk about molecular compounds. So we've already talked about ionic compounds. Now we're going to switch to molecular compounds. We're going to talk about how to name them given the formula and how to write the formula given the name, just like we did for ionic compounds. We'll talk briefly about acids, and then we'll kind of do a start of an overview or things to watch for as you kind of move forward. So the first section here is titled Molecular Compounds and Acids. And again, we're going to start by talking about binary molecular compounds. Again, binary means we're made of two different kinds of atoms. So remember, when we're talking about molecular compounds, our question always is, how do we know it's a molecular compound? And we're going to know it's a molecular compound because the compound is going to be made of two nonmetals. Remember, our nonmetals are to the right and above our heavy stair-step line on our periodic table. Because these are molecular compounds, there's no ions involved in this. So we don't use ionic charges. Okay, and there are no ions. Okay, so we won't be looking at, getting 8 valence electrons and do we gain or lose electrons. Gaining or losing electrons, those are ionic compounds. Molecular compounds, we're going to be sharing electrons. In molecular compounds, we use prefixes to indicate the number of atoms of each element, and the second atom always ends in "ide." Okay, so the difference with names of molecular compounds is that they're going to have prefixes before each atom. Oftentimes, these compounds, these nonmetals, will often combine in more than one way. So what I mean by that is, for example, right, hydrogen peroxide is hydrogen and oxygen, but peroxide is H2O2. Water is hydrogen and oxygen, that's H2O. So oftentimes you're going to see binary molecular compounds where there'll be several different types of compounds that are composed of the same two types of atoms, okay? There'll be different ratios of those elements. The prefixes tell how many atoms of each element are present in each molecule of the compound. So the prefixes are going to tell us how many atoms of that particular element there are in that compound. So to name a binary molecular compound, use the following guidelines. Number 1, we're going to write the names of the elements in the order that they're listed in the formula. Number 2, we're going to use prefixes appropriately to indicate the number of each kind of atom if there is just one atom of the first element listed in the formula. You can leave off mono. Third, end the name of the second element with the suffix "ide." To write the formula of a binary molecular compound, first use the prefixes to tell the subscript of each element. Then you're going to write the correct symbols for the two elements with the appropriate subscripts. So again, if we're naming a binary molecular compound given the name, okay, we're going to write, or given the formula, we're going to write the names of the elements in the order they're listed in the formula. We're going to put prefixes on each of the elements to indicate the number of each kind of atom. If there's only one of the first atom, we can leave off the mono, and we're going to end the second element in "ide." If we're writing the formula given the name, the prefixes tell us the subscript of each element, and we write the symbols on the appropriate subscripts. So generally we say subscripts equal prefixes. Whether we're naming or writing the formula, subscripts equal prefixes, prefixes equal subscripts for ionic compounds. So table 6.5 in your textbook are the prefixes used in naming binary molecular compounds. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Now again, these are not something you have to have memorized because they are on your helper sheet, right? This is a picture of the bottom box of your helper sheet, and notice I give you these prefixes. So these are not prefixes you have to have memorized, okay? I give you that information on your helper sheet. So if we want to do a little practice with this, basically I kind of want you to kind of go back and forth. So for these first three, I'm giving you the formula, so I want you to name them. And for these final three, I'm going to give you the name. I want you to write the formula. So again, take a little bit of time. If that means you need to take more time and pause the video, do so. But for the top three, I want you to write the name, so name these compounds. In the bottom three, I want you to write the formulas. So the first formula we see is OF2. So the first question we have to ask is whether this is ionic or molecular. We know it's a molecular compound because oxygen and fluorine are both nonmetals, so that makes it a molecular compound. So to name a molecular compound, we're going to write the names of the elements in the order they are, and the second element has to end in "ide," and subscripts become prefixes. So there is no subscript on oxygen, so you can still have the mono, oxygen. On fluorine, the prefix is 2, so that's di. And then fluorine has to become fluoride because it has to end in an IDE ending. So this is monooxygen difluoride, or just oxygen difluoride. For Cl2O8, Cl is chlorine. The 2 means there's 2 of them, so it's going to be dichlorine, and it has to be the INE ending because it's only the second element that ends in "ide." 8 is octa, and oxygen becomes oxide, so it's octoxide. So dichlorine octoxide. For SO3, again, I have 2 nonmetals, so I know it's a molecular compound. So again, I'm going to use prefixes for the subscripts. On sulfur, there is no prefix, which means it's 1, so I can have mono, but that's kind of optional. Sulfur. The 3 means tri, and oxygen becomes oxide. So monosulfur trioxide or just sulfur trioxide. Remember, the mono is optional when there's only one of the first elements. of the first element. All right, the next one, I'm given the name I need to write the formula. So I'm going to do my symbols first. Nitrogen is an N, fluoride is an F, but no charges are crisscrossing, none of that. Remember, our prefix tells us our subscript. So there is no prefix on nitrogen, which means it's 1. Tri means 3, so my formula is NF3. For disulfur dichloride, sulfur is S, chloride is Cl, disulfur means there's 2 sulfurs, dichloride means there's 2 chlorides. And again, we don't make it the lowest whole number ratio with molecular compounds. We just leave it S2Cl2. Lastly, we have dinitrogen tetroxide. Again, my symbol for nitrogen is N. For oxide, it's O. Di means 2, so I have a subscript of 2 on nitrogen. Tetra means 4, so I have a subscript of 4 on oxide. So N2O4 is dinitrogen tetroxide. So again, the important thing here is, right, our subscripts become prefixes, and our prefixes become subscripts. And we have to remember that our second element ends in "ide." In terms of acids, I don't typically call things by their acid names, but I would like you to know what acids are. Acids are compounds that produce hydrogen ions when dissolved in water. So typically, the formula for an acid is going to be a hydrogen ion and an anion, okay, combined in such a way so that they are neutral. So that kind of relates to why I typically don't call them acids for you. I typically am going to call them like an ionic compound. So Mrs. K will not call by the acid name, but as an ionic compound. Another way to define an acid is to say that it is a compound that contains one or more hydrogen atoms and produces hydrogen ions when dissolved in water. So, for example, I will not call phosphoric acid phosphoric acid. I'm going to call phosphoric acid the ionic compound hydrogen phosphate. So if I want you to write the formula for phosphoric acid, I'm going to say hydrogen phosphate. And you're going to write the formula for it the same way you do ionic compounds. So remember, our steps for ionic compounds is we write our symbols, we write charges, we crisscross, we make sure it's the lowest whole number ratio. Symbols, charges, crisscross, lowest whole number ratio. Symbol for hydrogen is H. Its charge is +1. Phosphate you have memorized is PO4 with a charge of -3. I crisscross down. I don't need parentheses. So phosphoric acid that I would call hydrogen phosphate is H3PO4. So there might be a question on your homework that asks about acids. In your textbook, there's a chart and it tells the acid name and what its formula is. But on a test or quiz, I will never call acids by their acid names. I'm going to name them as if they're an ionic compound, and you will just write the formula for it just the same way you do writing the chemical formula for any other ionic compound. The last section is really just a summary because up until this point, right, in the section about ions and the section about ionic compounds, you sort of knew you were writing formulas for ionic compounds. In the section about molecular compounds, you knew you were writing formulas for molecular compounds. But on homework and on a test and a quiz, you won't necessarily do that. You won't be in the section where they're all ionic compounds or all molecular compounds. So this last section's about a summary of writing them. Tomorrow we're going to make a flow chart. Today we just kind of want to finish up some notes. Okay? So, in preparation for making a flow chart tomorrow, as in your notes, today we're just going to kind of go over some general suggestions from me and from your textbook, again, to help you with this. So, number 1, okay, remember that in an ionic compound, okay, the net ionic charge is 0, right? So what that means is our total positive charge has to equal our total negative charge. Okay, our compound has to be neutral. If we have an "ide" ending, it's probably a binary compound. Now, it can be both an ionic or a molecular compound because binary just means made of 2 atoms, so it means there's no polyatomic ions in it, okay? So remember, a monatomic nonmetal, right? Fluorine becomes fluoride in a compound because it becomes an anion. So binary compounds end in "ide," both ionic and molecular ones. Okay, oops. Thirdly, if we have an "ite" or an "ate" ending, right, we have a polyatomic ion, which means it has to be an ionic compound, right? Our ways of telling the difference is molecular compounds are made of 2 nonmetals. Ionic compounds are a metal and a nonmetal, or they contain a polyatomic ion. So if they have a polyatomic ion, it's an ionic compound. Okay. And those polyatomic ions are going to have oxygen in them. Usually, prefixes are probably a molecular compound. Sorry. Now, I say probably because if you look really quickly at your helper sheet, there are a couple polyatomic ions that have prefixes in them. Dihydrogen phosphate, dichromate. Okay, so, but you should know that those are polyatomic ions because they ended that 8. Again, prefixes and an element that ends in "ide" mean you likely have a molecular compound, a compound made of 2 nonmetals. And remember, we're going to name compounds with metals with more than one possible charge. Twice. And somehow that information has to be given to you. In the stock system, remember, you'll have a Roman numeral, and that Roman numeral is equal to the charge on the ion. With the classical system, you'll probably have to use your helper sheet because it's going to use that Latin root in either an us ending if it's the lower charged, or an ic ending if it's the higher charged of the 2 ions. Last suggestion, again, typically, no, really, that kind of summarizes all of it. So that's a good spot for us to stop. Tomorrow, I know that you're out of room probably on your outline. Tomorrow, you're going to want to have a blank sheet of paper, and we're going to make a couple flow charts that you'll follow so that no matter what kind of compound it is, you'll use the same flow chart to figure out its formula and to write its name. Your homework is on page 160, questions 39 through 42. Have a good day. Talk to you tomorrow.